This section we're going to be going over the law of sines. This is going to result in a couple equations or formulas, and then at the end of this section we'll also go over a couple area formulas as well. So everything we've done up to this point has been working with right triangles for every triangle that we've worked with. So now we're going to be working with what's called oblique triangles, and these are going to be triangles without a right angle. So just for a random looking example, this triangle right here would be an oblique triangle because there is not a right angle. There's no 90-degree angle in this oblique triangle. So when we label the sides and the angles of the triangles, we typically use capital letters for the angles, and then we use lowercase letters for the sides. The one thing to keep in mind that's basically always true, which how we do the notation, is that the same letter is across from each other. So for example, like you see here, we have angle A, and then the side across from it is side A. Then we have angle C. The side across from it that it opens up to is side C. Angle B, it opens up to side B. So make sure you keep that in mind because that's always true for these oblique triangles. So this is going to be the law of sines, where it's this essentially equation or formula, and we're going to be using this to help us solve the triangles. When we're solving triangles, that means we're just finding all of the sides and all of the angles in the triangle. So what's going to happen is we're always going to be given 3 pieces of information. And that the information is the sides or the angles. So the tricky part for this, I guess I forgot to mention what the law of sines actually says. Sorry. The law of sines for a triangle ABC is side A over the sine of angle A equals side B over the sine of angle B, side C over the sine of angle C. And notice that it kind of looks weird, right? Because we have these 2 equal signs. But what we're going to do usually when we actually use the law of sines is we're just going to use 2 chunks at a time. So for example, we might use this portion right here. We might use this portion right here. Or we might use this portion right here. So even though we have all 3 of these set up right here, we're only using 2 at a time just so there's the 1 equal sign. So the tricky part for when we're actually trying to solve a triangle and solve for all of the sides and all of the angles is the type of triangle that it is going to actually tell us the steps that we need to perform in order to actually solve for the missing pieces. So we're going to go through 3 techniques for this section and how we're going to actually solve these triangles. So this is going to be the first type of triangle. If one side and 2 angles are given, if one side and 2 angles are given, this would make it an S, so S for side, A for angle, an SAA or an ASA triangle. Then in my opinion, this is usually the easiest type of triangle to end up solving. The first thing we're going to do is solve for the other angle first, using the fact that all angles need to add up to 180 degrees for the interior angles. And then we're going to solve for the other sides using the law of sines. So let's jump right into an example here. I'll just do one of these. Solve the triangle ABC, where C is 56, capital A is 46 degrees, capital C is 63 degrees. And sometimes you're going to have to create the triangle yourself. This is actually nicely drawn in here for us already. So let's go ahead and label all of the given pieces of information. So we have these filled in, and it looks like we need to find side A, side B, and angle B. So just something to keep in mind when you're actually solving the triangle, the side that is long, or rather the angle that is largest should open up to the side that is longest. So let's go ahead and get started. The first step, like we saw that was mentioned on the previous page, is find the angle. So we're going to find B, the angle B first. Also, if you wanted to label this triangle, you know that you're going to use this technique because this is a side angle angle triangle. So side angle angle, that's how you know to use the technique that we're about to do. So finding angle B, finding angle B, we're just going to use the fact that if you add up all of the angles for the interior angles of a triangle, it's going to equal 180 degrees. So we're going to have A 46 degrees. We're looking for angle B. C is 63 degrees. And you're basically just solving a really straightforward linear equation. So I'll leave that for you guys to finish off, but we would end up getting 71 degrees. So you add up 46 plus 63, subtract that value on both sides, we get B equals 71 degrees. If you want to label them as you go in here, that's fine. I'm just not going to. So we found B. We have two more things to find. We have side A and side B, and it doesn't matter which one we find first. Let's find side A first. So step 2, we're going to find side A, and we're going to do this using the law of sines. So the law of sines says we're going to have side A over sine of angle A equals, and then this is where we have to make a choice. Either it's going to be B over sine of B or C over sine of C. So based on what we have here, we actually have to use side C over sine of angle C, right? We don't have side B just yet, so we have to use C over sine of C, and then we can go ahead and plug everything in. So we're looking for A over sine of 46 degrees equals side C of 56 over sine of angle C, which is 63 degrees. And even though this looks kind of annoying to figure out here, it's usually not that bad. All we have to do to get A by itself is multiply sine of 46 degrees on both sides, so it ends up multiplying on the right. So to get little a by itself, we're going to multiply this on both sides. So it's going to be 56 times sine of 46 degrees over sine of 63 degrees. And usually a good idea is to not round anything until the end. So just leave everything as it is until the very end. Now you can plug this entire thing in the calculator. Make sure you are in degree mode. And we would end up getting, I'm going to round this to the nearest tenth, 45.2. So we have side A is 45.2. And then the last step here is going to be to find side B, which once again, this is going to be using law of sines. So B over sine of B. And then once again, this is where we have another a choice to make. We can use A over sine of A or C over sine of C. It actually doesn't matter. You can use whichever one you want. So if you want to use A over sine of A, you can, because we now have little a and big A. Or what I'm going to do, and what I kind of recommend doing this just in case, if you have the choice to use the values that are given to you, just use those values, because then you're not usually working with decimals. And if you messed up finding little a, then that mistake will not carry over for finding little b. So now we can go ahead and plug everything in. That's going to be B over sine of 71 degrees equals little c 56 over sine of angle C, so sine of 63 degrees. And you basically just solve this the same way we just solved the one on the left. We're going to multiply sine of 71 degrees on both sides. So 56 times sine of 71 degrees over sine of 63 degrees. Plug this in the calculator. I'm going to round this to the nearest tenth once again. And we end up getting about 59.4. So like I mentioned at the beginning of this problem, just maybe do a quick little double check. Make sure that whatever your largest angle is opens up to the largest side. The largest angle is angle B, 71 degrees. So that means side B should also be the largest. And it looks like side B, 59.4, is in fact the largest side. So just a nice little check to make sure that we probably did this correctly. Okay, so once again, this is for a side angle triangle. Find the missing angle first, then use law of sines to determine the two missing sides. So for the next one, I'll skip the next one. Maybe try this one on your own, because it's the same exact process where we have two angles and the side. So you do the same exact steps. So try that on your own. Make sure you're comfortable with that process. Now for probably the trickiest type of question here. That's going to be when we have two sides and one angle opposite one of those sides, which is a side angle triangle. So we have two sides and we're given one angle opposite one of those given sides. The reason why this one's the most annoying is because this does not necessarily just result in one triangle like the previous one that we just did. This might result in one triangle, everything works out fine, or it might result in two triangles, or two possible triangles, or it might result in no possible triangle. So we have three possibilities. As soon as you know you're working with a side angle triangle, it's either going to be one triangle, two triangles, or no triangle. So the very first step for these questions when we have a side angle is we're going to find the angle opposite the side using the law of sines. So remember, we end up having two sides and one angle opposite one of the sides. So we're going to find the angle opposite the other side first. And when you try to do this using law of sines in the calculator, if you end up getting a domain error, that means there's no triangle. So as soon as you do this first step, if you get a domain error right away, that means there's no triangle, which is honestly good because then you're done. You just say no triangle is possible, and then you don't have to do anything else. So if you don't get a domain error, if you actually get an actual value here, then you have to check, is it going to be one triangle or two triangles? So you're going to take whatever angle that you actually have, that you actually got from plugging in the calculator from step one. You're going to subtract that angle from 180 degrees. And then you're going to add that result to the angle that was given originally. If that result exceeds 180 degrees, then there's only going to be one triangle. If it does not exceed 180 degrees, then there's going to be two triangles. So we'll see why this is when we see these two examples in a second here. But once you subtract the angle from 180 degrees that you just got, that's going to be the third, or rather the second triangle's angle. So let's just jump into an example just so we can see how this works, so it makes a little more sense. So let's say this is going to be the example where we just end up getting one triangle. It's going to be a side angle triangle, but let's say we have no idea. Let's just say we are given these values right here, and then we're going to determine that it's a side angle, and we'll also determine that it does end up in fact being one triangle. So solve the triangle ABC, where little a is 81, little b is 62, and capital A is 43 degrees. So one reason right away, without drawing, I'm not going to draw out each triangle necessarily, but you know this is a side angle triangle because you have two sides, and then the angle that's given is an angle that's opposite one of the sides. So if this was capital C in here, this would no longer be a side angle triangle. So if it really helps you, you could always draw these out. So let me just draw this out real quick. So here are the values filled in. Obviously, it doesn't have to be drawn to scale. So if we go ahead and just run it through this way right here, you can see that we have a side the next piece of information is a side, and then we have an angle directly next. So side, side, angle, triangle. So we need to find little c, big B, and big C. And of course, the order in which we find these will usually matter. So the first step, based on what we just saw written above, when you have a side, side, angle, triangle, the first step is going to be find the angle opposite the other side. So this is going to be find angle B. And we're going to do this using law of sines. So it's going to be B, it doesn't matter how you write it, which way you write it, B over sine of B equals A over sine of A. So I mentioned it doesn't matter which way you write it, meaning you could have written the A's on the left side, B's on the right, it doesn't matter. So this is going to be filling everything in, 62 over sine of B equals 81 over sine of 43 degrees. So this is a little bit different than what we were doing in the previous couple pages here, because now we're looking for the angle using law of sines. So we need to start this kind of the same way. We're going to solve this by cross multiplying. I'm going to do this in one step. Let's go ahead and multiply sine of B to the right hand side. So multiply sine of B to the right hand side. And then in one step, let's go ahead and multiply sine of 43 degrees to the left, and then divide 81 to the left. So we get sine of B equals 62 times sine of 43 degrees divided by 81. So in order to solve this for B, we need to remember our inverse properties. To solve for the angle, we need to do the inverse trig function on both sides, technically. So we're going to do sine inverse, B equals sine inverse of 62 sine of 43 degrees over 81. So this, of course, looks really, really messy, but you're just going to go ahead and plug this directly into the calculator in degree mode, and we end up getting capital B equals 31.5 degrees. So we just got the angle, 31.5 degrees for B. So right away, always keep in mind when you have this set up, we might have no triangle, one triangle, or two triangles. Since we actually got an answer here, we're either going to have one or two triangles. So before we finish the next steps here, we want to check, do we have one or two triangles? So this is going to be the steps mentioned above that probably seemed kind of confusing. We're going to subtract this angle from 180 and then add that result to the initial angle. If it's greater than 180, there's one triangle. If it does not exceed 180, then there's two triangles. So we're going to go ahead and we're going to take this value. We're going to subtract it from 180. So 180 minus the 31.5. We get 148.5 degrees. Then we're going to take that 148.5 degrees and we're going to add the initial given angle, which was 43 degrees. So we end up getting 191.5 degrees. So now this is where we form this conclusion. This value right here, since it's greater than 180 degrees, there's only going to be one triangle. Which is honestly good because then we only have to do this process once and we don't have to do it twice. So if we got less than 180 here, then we would end up having two triangles, because remember, the interior angles have to be able to add up to 180 degrees. So if this is already over 180, that doesn't give us a possibility for another triangle. Okay, so what we can do, don't think this angle actually means anything here for like what our sides and angles are. We can ignore that for the rest of filling this in. So we need to find two more things. It looks like we need to find, let me scroll up here. We need to find little c and big C. So I'm going to go ahead it's usually easiest if you just find the angles. When the orders doesn't matter, the order doesn't matter here. If the order doesn't matter, I just like to find the angle first because it's a lot easier, because we already have 2 of the 3 sides. So to find the missing side, we just use the fact that the sum of the interior angles adds up to 180 degrees. So side A, or angle A, is 43 degrees. Angle B is 31.5. We're looking for C. So add up A and B on the left, subtract it on both sides, and we end up getting 105.5 degrees for angle C. So for the last step is going to be find side C. And anytime we are finding a side in this section, we're using the law of sines, because that's really all we learned so far. So that's going to be finding side C, C over sine of capital C. And then it doesn't matter. We can use B over sine of B or A over sine of A. I'll just use A over sine of A. And then we can plug everything in and solve for little c. I'll leave this for you guys to try to practice, just because we've done law of sines several times already. So find little c, plug in all of those 3 other values right here and here, and we should end up getting 114.4 for side C. So as always, we are given 3 pieces of information, sides and or angles, and we need to figure out the other 3. And we do that by first figuring out what kind of triangle it is. This one we were told it was a side-side angle, but the way that you can tell by just looking at this right here is that you have 2 sides, and then the angle is opposite one of those sides. So let's go ahead and see this next example. It's going to be very similar to this one, except, as we kind of have a spoiler alert, same type of triangle, side-side angle, but we're actually going to end up getting 2 separate possible triangles based on these initial conditions. So right away, the setup's pretty similar. We have side A is 54, side B is 62, and angle A is 40. So without drawing, I'm going to draw them out in a second because we're going to end up with 2 separate ones. But we know it's a side-side angle because we have side, side, and then the angle is opposite one of those sides. So it looks like before we start our little process here, I like to always write this down. We need to find side C, angle B, angle C. And then for step 1, remember, if you have a side-side angle triangle, step 1 is always to find the angle opposite the other side. So find angle B, and that's going to be using law of sines. So it's going to be B over sine of B equals, it looks like we have A, little a and big A, so A over sine of A. Plug everything in. And we need to solve this for angle B, which this is always when you're using law of sines to find an angle, it's always a little bit trickier. So I can go ahead and do what we just did in the previous page, essentially cross multiply to get sine of B by itself. So it's going to be sine of B on the right-hand side, and we can go ahead and multiply sine of 40 degrees to the left, and then divide both sides by 54. So to get B by itself, we're going to do sine inverse of the other side. So sine inverse of that big mess, which as always looks very complicated, but just make sure you plug this in the calculator in degree mode, and we end up getting B is approximately 47.6 degrees. Obviously, if you're doing this on like homework or exam or whatever, you'll see what to round to. I just rounded this angle to the nearest tenth. So now for the annoying part is the fact that since we have a side-side angle triangle, we need to check, do we have 1 or 2 triangles or none? Or sorry, not or none. If we ended up getting a domain error in the calculator, that's how we know that we would have none, but we didn't, so we have 1 or 2. So we ask ourselves, 1 or 2 triangles, we're going to take that value that we just got, subtract it from 180. So these are the same steps that I mentioned on the previous page that are written down that we just did. So subtract that from 180, we get 132.4 degrees. And then we take this value and then add it to the original angle that was given, which was 40 degrees. So we take the answer that we just got, add it to the original angle, we get 172.4 degrees. So this angle, this obviously isn't one of the interior angles. Once again, this is just telling us whether or not we have room to have another possible triangle, which we do because this is less than 180 degrees. So since this value is less than 180 degrees, this is going to end up giving us two triangles. Okay, so here's the annoying part. Let's go ahead and set up these two triangles down here. So let's take a look at triangle 1 on the left. I'm going to start this off. I'm going to draw these out just so we have a nice little visual. I'm going to start by drawing this out given these values that we started with. So these are the values that we just were given to us. Side A, side B, angle A. And then the other angle that we just found, angle B, is going to be 47.6 degrees. So triangle 1, if you have two triangles, triangle 1 is going to be the B value that you found initially. Now, so we can see the difference for triangle 2, let me draw this out. I'm going to try to draw it to scale. You never actually do have to draw it to scale. You never have to draw it. I'll try to draw this to scale though a little bit. And it might look something like this, hopefully. So now the question is, for this second triangle, what's the value of angle B? So it is not this value up here. It is not the 47.6 degrees. That is only for triangle 1. So the question is, what is this other angle for angle B? So every time you figure out there's two triangles, the other angle B is going to be this value right here, after you subtracted it from 180 degrees. So if you end up having two triangles, that is the other value for angle B, that 180 minus the other initial angle B. So 132.4 degrees. And plug that in. And I'm just going to write both of these values for B separately. So this first one was the initial B that we found, and this other one was the 180 minus the initial one. And even though this looks super annoying, we are almost done. We just have to find two more things from each of these. So I'm going to call both of those our step 1, where we found the other angle. Step 2, we still need to find the C, capital and lowercase c. And like I mentioned before, usually when the order starts to not matter, I like to find the angle first, just because if you have two angles already, it's just really easy to find the third, using the fact that the sum of the interior angles has to add up to 180 degrees. So for both of these, it's going to be A plus B plus C equals 180 degrees. We just have to make sure that we're using the correct B. Plug it in. I'll leave it for you guys to check. The one on the left, we would get 92.4 degrees. The one on the right, so we do the same thing, A plus B plus C. Just make sure you're plugging in the proper B equals 180 degrees. Solve this for C, and we would end up getting something probably pretty small. Yeah, 7.6 degrees. And then we have to find one more thing, and that's going to be finding side C for both of these. I'm doing these at the same time just so we can see the similarities, because we're literally doing the same thing, just with different values. So even though it's super annoying that we have to do two of them, you're just doing the same steps. So let's look at the one on the left. This is going to be little c, using law of sines here. Remember, all we learned so far in order to find the sides of a triangle, is law of sines. To find an angle, we either use the fact that the sum of the interior angles is 180 degrees, and sometimes we should use law of sines also. So C over sine of C, and we have everything else that we need. So we can use B over sine of B or A over sine of A. It doesn't matter. Just plug in your necessary values. I'll leave it for you guys to go ahead and check. Side C for this one should be 83.9. And then for the one on the right, we're going to do the same exact thing. C over sine of C equals A over sine of A. The A's are going to be the same. The only difference between these two, left and right, is going to be the angle C that we just found. Plug everything in, and we would end up getting C, side C is 11.1. So once again, once you have it set up like this, obviously I didn't show all of my work, so it makes it seem a lot easier than it might be. Let's just do a quick little recap for this. We recognized it was a side-side angle triangle. We have two sides. The angle is opposite one of those sides. So right away, we want to find the angle opposite the other side using the law of sines. We find this angle was 47.6 degrees. Then we try to figure out, since we actually got an answer, we want to know, do we have one or two triangles? So we always take that value, subtract it from 180, and then take that answer, add it to the original angle. If that answer is less than 180, we have two triangles. Greater than 80, we have one triangle. Since it was less than 180, we had two triangles. And then this B on the left is going to be for triangle 1. This one on the right is for triangle 2. So then you just create both of your triangles with your separate values for B. Then step 2 for both of these is find the missing angle using A plus B plus C equals 180. Step 3, find the last side using law of sines. So as long as you know what steps to apply, it's always going to be the same steps. You just have to know which to apply when, essentially. Right, so let's go ahead and see one more, and then I'll kind of talk about a quick little brief summary. So this last one is going to be the same setup, side-side angle. We have two sides. The angle is opposite one of those sides, except we'll see how we know it actually results in no triangle at all, which is honestly great because we won't have to actually do anything. So we have A is 51, B is 71, angle A is 75. So we're going to start this off the same way. We want to find the angle opposite the other side that we are given using law of sines. So B over sine of B equals A over sine of A. And we can go ahead and plug everything in. 71 over sine of B equals 51 over sine of 75 degrees. And solve this the same way we've been solving it. I'll put dot, dot, dot. We would end up getting B equals sine inverse of 71 times sine of 75 degrees all over 51. So if you end up plugging this into the calculator, you're going to end up getting domain error. So what that means, domain error, as soon as you do this first step, that means there's no possible triangle that you can actually create given this initial set of information up here. If you try to create one, it might look something like this, which obviously is not a triangle because it doesn't actually reach. So the sides are either not long enough, the angles are not short enough for this to be an actual triangle. Okay, so one more type of question for this section, probably a little bit easier than what we've been doing. It's going to be the area of an oblique triangle. So we probably know that the area of a triangle is 1/2 base times height, right? So we probably already know just by looking at this little triangle that we have set up here. There's going to be more than one way to do this, but the base, just based on how we have this written, the base would be C, right? This would just be the length of the base would be C. The question is, what is the height? So the height of this triangle would be this vertical line directly down the middle, creating a right angle at the bottom. So the question is, what is that actual height using A, B, or C that we can actually use here? So just for now, I'm going to call this D, and we can actually figure out what D is maybe over here on the side using some right triangle trig. So before we just write D equals, let's just look at this triangle, this right triangle here. You can do the same thing for the one on the left if you wanted to. We can rewrite this in terms of angle B. We can say that sine of angle B equals opposite, which is D, over hypotenuse, which is A. So the reason why I wanted to do this is because we needed to include D, because now we can solve for D by multiplying A on both sides and getting D equals A times sine of B. So you might be saying to yourself, well, that is not helpful at all, because now instead of D, we have A sine of B, but it is helpful because we know or can figure out A and sine of B, or just B, because that's part of our triangle, whereas D is technically not a side in our triangle. So D is the height. So we can actually go ahead and replace this with A sine of B. So based on this setup that we have right here, the area of this triangle, 1/2 times the base times the height, 1/2 times C times A sine of B. That is one formula for this triangle. So instead of only having one setup for these, you have a couple different setups, just because you can think about the base being from 3 different sides. So the one that we just created would have been 1/2 C times A sine of B. So we just basically figured out this one right here, 1/2 AC sine of B. You could also have 1/2 BC sine of A, 1/2 AB sine of C. So all of these would be correct no matter which one you used. Sometimes you can only use one of them based on what's given to you. Just notice that it's actually not that bad to remember. You could always derive it like we just did a second ago, but it's not that bad to remember because we have 2 sides, and then the angle inside of sine is just the other letter. So we have side B and C, and then it's angle A that we're using, side A and C, angle B that we're using, sides A and B, angle C that we're using. So let's just see one example of this. We have find the area of a triangle having 2 sides, length 24 meters, 10 meters, and an included angle of 62 degrees. So we can go ahead and fill this in. We have angle A, B, and C. So this is 62 degrees between. So what I'm going to do, let me just do this first. Let me do the angle last. So let's say that this is side 24. This is side 10. And this would end up being little b. This would end up being little c. The included angle of 62 degrees is the one between them. So if it says included, it's the one between both of the sides. So that would be angle A. So it does not matter where you put the sides. You could have put side B, side A, and side C. As long as the angle is between them, no matter which formula you use up here, you'll get the same exact answer because it'll all be exactly the same. So just based on the way that I wrote this down, it looks like we're going to be using this one right here, 1/2 BC sine of A. So we have the area equals 1/2 B times C times sine of A. So we get 1/2 24 times 10 times sine of 62 degrees. Just plug that in the calculator, and we end up getting an area of about 105.9. Since this is in meters, the area would be square meters or meters squared. All right, so basically, long story short for this area formula, it's going to be 1/2 times side times the other side times the sine of the angle between them. All right, so just for a quick little recap of, without looking, we just did the area. I'm not going to recap that because we just talked about it a second ago. But we had two types of triangles. Technically, we had three types. We had a side angle angle and an angle side angle, and then a side side angle. The reason why I think about these as two instead of three is because for these first two, side angle angle and angle side angle, you solve them the same way. You solve for the other angle using a plus b plus c equals 180 degrees, and then solve for the other sides using law of sines. And just so we can tell the difference here, if you're given little c, something that looks like this, little c, capital A, capital C, this would be an example of a side angle angle, because you have a side and then an angle and then an angle directly in that order. It doesn't skip something. You just have side and then angle and then an angle. And then for angle side angle, that would look something like this. Angle C, side A, angle B. Probably a little bit more obvious to tell. It's just an angle, side, and then an angle if you go in that direction here. So that one's probably a little bit more obvious for angle, side, angle. Either way, you have two angles and a side, and that's how you perform the steps to finish solving those two triangles. And then, of course, the one that's a little bit annoying, side, side, angle. So that might look something like this, where you have a side, another side after, and then the angle directly after. So notice I'm always kind of going just counterclockwise here for all of these, counterclockwise, counterclockwise. So not to make this overly confusing, but side angle angle could be angle angle side as well. And we know for the side side angle triangles, this could result in 1, 2, or no triangles. We always solve for the angle opposite the other side first using law of sines. If we get domain error, there's no triangle. If we get an actual value, it's 1 or 2 triangles. If it's one triangle, that's when we do the 180 minus that angle and then add it to the initial angle. If that value is greater than 180, there's one triangle, finish solving it. If it's less than 180, there's two triangles, and you have to finish solving both of those two triangles. So either way, you have to recognize what type of triangle it is based on what's given to you. Follow these steps, and it'll always be correct. All right, so that's it for this section.